Alright, welcome back you guys to another homework video. This time we're tackling the semester 2 homework 4. And so you guys were told to create a method that would find these special squares, which are obviously perfect squares, and then also the sum of integers 1, 2, 3, 4, so on and so forth. So you were given this class here, public class CV Math, and it has this method, find mid. And to be perfectly honest with you guys, I don't know why you were given this method. Um, I didn't end up using it in my solution. Dr. Neat doesn't end up using it in his solution. So I think the point of this exercise was to just say, hey, if you're given a class and you're told to add a function to it, just be able to do that. So I put my method here into the CV math class. You can see that find mid is up here, but I don't actually use find mid in this code. If you used find mid, that's great, but I did not, Dr. Neat did not, so I wouldn't worry about it too much. And then this is kind of an example of using the CV math class, so we have CV math.special square. I think I called it magic square. I did call it magic square, whatever you decided to call it. And then also CV math.find mid. So let's go ahead and jump right into it. So here's my method. So let me just show you my starter. We'll get to these commented out guys in a minute. So I have declared CV math, and the CV math constructor doesn't have any parameters, and then I just have it run find us the first 3 magic squares. So let me show you that it works. Oops. Sorry about that. There we go. So we have, and then the comment numbers are like what their square roots are. Like 6 is the 6 squared is 36, and 35 squared is 1225, and obviously 1 squared is 1. So in terms of special squares, I counted 1 because it's the first step you do, right? So 1, just 1 plus nothing else is your summation at this point. And then 1 is a perfect square. So I counted 1 as one of these. If you did not, that's okay. But he gave you the examples of 36, and then the next one being 1225. And then also, if you didn't show what its square root is, that's alright too. But I went ahead and did that. So you can see that it works for our first 3 there. And then let me show you what I did to get that functioning. So we have public static void, magic square, because it's not returning anything. It's just printing everything out within the method. Notice that when I tell it to do this method, you don't have to tell it to system.out.print this method. You just run it, and then it does it for you. So we have a couple integers here. We have int a and int sum. A is 1, sum is 0, and then n is however many you want to find. So while n is greater than 0, which hopefully the first time when you put it in, it is, and if you're going to be like a funny guy or whatever and put 0, nothing will be returned. Which would be correct, because if you want 0 of them, you should get nothing. And then, so we have this while loop here, and then we go into another loop, which is just a while true loop. And then sum equals sum plus a, so the first time you do it, it's 0 equals 0 plus 1, so 1, and then you can see I have some a plus pluses down here, so then it ends up being 1 plus 2 plus 3, so on and so forth. And then double magic equals math.square root. So maybe this is a method that you haven't seen before, but this is from the math class, and the math class, you notice it doesn't have to be imported like ArrayLists or the PKG. You can use the math class, and it has methods like min, max, square root, power, stuff like that. So it's a really helpful method. Generally speaking, the methods return doubles, so we have double magic equals math.square root of sum. So we're going to be adding to sum, and then we're going to square root it and get this variable here. And then if magic equals int math.square root sum, so and then we're going to break. So you're probably looking at this and thinking, well, that's the same thing, isn't it? If magic is math.square root of sum, shouldn't int math.square root of sum be the same thing? Well, the interesting thing is that if you cast it as an int, if it's not a whole number, or in other words, if it's not a perfect square, right? If it has a bunch of decimals after it, and then you cast it as an int, it cuts all the decimals off. So if magic, which is the double, so this is the one that includes all of the decimal points, is the same as the one with all the decimal points like cut off of it, then you know that magic must be a whole number. And so if that's the case, then we're going to break it, and then we're going to print out sum, so whatever sum is, because sum is a perfect square. and then also what the square root of it is. So let me show you what I'm talking about with these decimals, because that's probably kind of confusing. So if we have 47, we know that 47 is not a perfect square. 49 is, but 47 is not. So we're just going to print out math.square root, and that's a double. And then we're going to cast it as an int, and we're going to print it again. So we'll show you what that gives. I think I saved it. Come on. There you go. Oh, I didn't. Sorry. Hold on one sec. Okay. Compile. Run. Okay. So this is our method, and then this is what I'm talking about. So you can see that 47 is not a perfect square. So when you evaluate as a double, you get this whole mess, right? 6.855 whatever. And then when you cast it as an int, even though this should round up if we're rounding normally, Java just cuts the decimals off, so it always rounds down. So you just end up with 6. So that would not be the same. However, if we do 49 for both of these, right? There we go. Now we have 7.0 and 7, and Java will count those as being the same thing, 7.0 and 7 being the same thing, so that if statement would evaluate to being true, and then we would break. But we'll never get, the reason that we don't get every perfect square is because we are summing, no, we're not just adding 1. Within the, if this if statement doesn't go off, we stay in the loop, we add 1 to A, and then we add A to sum, so the first time we go through is 0 plus 1, and then it's 1 plus 2, and then that ends up being 1 plus 2 is 3, 3 plus 3, and so on and so forth. So you get the summation, so it doesn't work out when you get 49, which is why we don't get all of the perfect squares. We get all of our special squares, like we were talking about, because we're square rooting the sum. So then, if we break this loop, we go back into the bigger loop here, and we print all this stuff out. And then we add 1 to A because we want to add 1 to A either way, otherwise it'll mess up our summation. You'll add the same number twice. And then we subtract 1 from N because we're telling it, hey, we found 1. And then when N gets to be 0, we found all the ones that they have requested, and we are good to go. So yeah, hopefully that makes sense. This is a good way to check if something evaluates to, if a method evaluates to a whole number. So casting as an int just cuts all decimal places off, and then you compare the double value to the integer value, and if they're the same, then they must be whole numbers. Math.square root, just the math class in general, is a good thing to know. You guys already know math.random. And then one thing I want to say is, why wouldn't you start A as 0? And I will show you, because then it counts 0 as being one of them, which is, I guess, sort of correct, but I wouldn't really call 0 a perfect square. I don't know. I guess it's kind of on the same page as 1. You can count it, I suppose. I just didn't really consider 0 to be one of them, so I have A starting at 1 so that it won't count 0. Yeah, and besides that, I think that about covers it. So hopefully that helped you guys out. Hopefully this whole square root business makes sense. And honestly, in my opinion, this homework was one of the more difficult ones you guys have had thus far. So hopefully you guys are able to figure it out. And if not, this method exactly, something similar. Or, if you manage to use find mid, that's great too. So, yeah, I think that about wraps it up. Have a great week, you guys, and I'll see you next time. Thank you.